Hello, we are Group 11. We are myself, Alexis Martinez, then Roberto Arnoso and Celine Holderbaum, and we will explain the project of Chapter 3 based on microcontrollers. This project is divided in 3 phases. The first one is a counter mode 10. The counter mode 10 counts up to 10 and can count upwards or downwards, depending on UDL that is our variable. The inputs are UDL, count enable, clear direct, and the clock. As an output, we have the value in binary, a 4 bits digit, and TC10. TC10 is a flag that tells us when the value has arrived to its maximum value. If the counter is counting upwards, its maximum value is 9. But if it's counting downwards, its minimum value is 0. And when it's 0, it has to go back to 9. So now we are going to explain the software of the counter mode 10. As we see, we are going to program it in C, and it starts with the init system. Then we must read the inputs, and in the init system, all the outputs are settled, usually at 0. Then we read the inputs, and we look if we have a clock flag. This works as an interrupt service routine, and if we have no flag, it writes the output that we have already set, and it reads the inputs again. If we have a clock flag, then the software goes to a finite state machine where it writes the outputs at output logic, and it computes the next state in state logic. As we see, it computes the value TC10 and the value BCD, or in binary, the 7 segments, to indicate with to the right. Afterwards, we must reset the clock flag to 0 in order that when we have another flag, it repeats this one.
This is the timing diagram. We see that when count enable is 1, the value starts to count. The UDL, when it's 1, the value starts to count up. It is 0, 1, 2, and when the value is 0, the value counts down. 2, 1, 0. Then here we see that another time is 1, and it counts down to 8, 9, 0. Then in the TC10, here is 1 when the value makes the change to 0, and 9 when it counts up, and in the other one, the TC10 will be 1 when the change will be to 9 at 0. The symbol of the fast 2, it is a counter mode 60, and we have the same symbol at the 10 counter, but the difference is that we have in the inputs the cell clock, that we have 2 modes. We have the fast mode, that it is with 20 Hz, and we have the slow mode, that it is with 1 Hz. The difference, we have a difference in the outputs. We have BCD for the units and BCD for the tens, and then we have a TC60. The timing diagram of the second phase. The difference is that we have 2 new outputs, the value unit that goes to 0 at 9 and the value tens that goes at 0 at 5. The TC60 works the same as the TC10. The one will be when we make a change to 0 and 5 or to 0 and 9, and the other one to 5 at 0 and 9 to 0.
My name is Arnoso, so now we're gonna break it up, the reading scheme of the machine and also the main plan of the machine, the main scheme. So first the data comes with here with the in inputs, and then here in the read inputs we have the clock flag. The clock flag is the rising edge or the falling edge that makes the machine start recording the information, start processing it. Because if the information, when as clicking, is not recorded by a falling edge or a rising edge, we have a glitch. So when you have the clock flag activated, the data came here, and here activated the ESR. It's like the interrupt protocol. In the interrupt protocol we have the output lag units, the state logic units, the output logic 10s, and the state logic 10s. Here the information is read. So here we have two VSNM. Here we have the counter 10, and here the counter 6 unit. Then the information came here to this chart in BCD, the flag unit, and in BCD flag 10s, and after the protocol is completed and all the buttons are already activated again, because when we came here, all the buttons are unable to attend this flag here. So then the information goes to the output, and finally the machine can write the solution. And here we're going to break down the ESR code in C. The protocol that ESR suffers when the information is detected by the rising edge that we talk later. So as you can see, this is the main program. You can code it in C. And up here we have this. This is like a variable that have to enable all the buttons and all the processors to attend this code. So here we enable all the buttons. Then we have to the in 0. Probably this gonna be an interrupt. So we're gonna give value 1. And after here, we're going to deactivate the button and put the clock flag 1 to start counting at this point when the case is found. We give the number 0 here, and we give the number 0 to another interrupt. So we're going to make sure that these two variables were interrupts. Otherwise, we can disable them. And after seeing the two cases, the ESR, we have to run again. So we enable all the buttons, and the information goes to the chart table that we show later, and after all, the information is written by the code.